Alright, this video is a continuation of what we learned in class about angle relationships. So we talked about parallel lines cut by a transversal and the types of angles that were made. Now we're going to talk about specific angles in triangles. So if you could take a look at question number 1, it says, what do the angles in a triangle add up to? So I'm going to show you a triangle, and we're going to figure out what the angles add up to in this triangle. So if you could take a look at the picture that I'm about to show you, we're going to figure out together what the angles add up to. So if you take a look at this diagram in front of you, we have three angles. Our three angles are the 46 degree angle right here, the 57 degree angle, and the 77 degree angle. So let's add them all together. So I'm just going to add 46 plus 57 plus 77, and it ends up being 180 degrees. I'm going to change this around, so I'm going to move where B is. I'm going to move the A right here. And then I'm going to move the C, so that way I end up getting a completely different looking triangle. So this right here is telling me this is 107, this is 24, this is 49. So I'm going to figure out what these values add up to. So 49 plus 107 plus 24 gives me the 180 degrees that we will always get. So I'm going to actually make it where I'm calculating all the values. So I'm going to add angle A plus angle B plus angle C, the measurement of the three angles. And it says that it's 180, okay? But watch what happens when I change the location of angle C. Notice how the angle measurements themselves are changing, but this 180 is staying constant. It's never changing, okay? What if I were to change where A is? Same thing, the angle values are changing, but this 180 is staying constant. Same thing with this angle B. All right, so that means that we can officially say, well, almost officially say, that the angles in a triangle will add up to 180 degrees. Next time I see you in class, we're going to do a little bit more of a formal proof to show that it really is always going to be 180 degrees. So let's apply this information to question number 2. It says if a triangle has two angles with measures of 39 and 81, what is the measure of the third angle? So I'm going to draw a picture of my triangle, and I'm going to label in the information that I know. So I know that this is 39, I know that this is 81, and I don't know what my third angle is, so I'm going to call it x, but I do know that my three angles will add up to 180. So I'm going to say x plus 39 plus 81 equals 180, because again I know that they're always going to add up to 180. So that means that I can just solve this like a normal equation. So when I add 39 and 81 together, I end up getting 120. So x plus 120 equals 180. Subtract 120 from both sides, and I end up getting x equals 60 degrees. And that's how you do question number 2. So number 3 asks us to, it gives us the information about what we know about angle or triangle ABC. We know that the measure of angle A is 4x, the measure of angle B is 3x plus 1, and that the measure of angle C is x minus 13. And then it asks us to find x and to find the measure of each angle. So what I'm going to do is I'm going to draw a picture of it just like I did before, and I'm going to show what it looks like. So I know that I have angle A right here, and then I also have angle B and angle C. Alright, now I know that the measure of angle A is 4x, so I'm going to label this inside of here as 4x. I know that angle B is 3x plus 1, and I know that C is x minus 13. So I can go ahead and create an equation in order to solve for x. I know that it's a triangle, which means that the angles will always add up to, hopefully you said 180. So I'm going to take all of my angles and add them together. So the angle A is 4x, and then angle B is 3x plus 1, and angle C is x minus 13. And I know that that's all going to add up to equal 180. So all I have to do is solve my equation. by first combining like terms. So I end up getting 4x, 3x, and x, and that gives me 8x when I combine them. And then I end up getting 1 and negative 13, which gives me negative 12 when I combine them, and that's equal to 180. Now I just have to solve the equation by adding 12 to both sides, and I end up getting 8x equals 192. Divide both sides by 8, and my answer is x equals 24. Now, that is part of the question because it asked us to find the value of x and the measure of each angle. So I'm not done, but I'm in really good shape right now for what it is that I need to do. All right, so now that I've found the value of x, I need to find the measure of each angle. So what I'm going to do is plug 24 in right here, this 24, every time I see an x. So for example, the measure of angle A is equal to 4x. So I'm going to say that it's equal to 4 times 24. All right, and then I'm going to go ahead and multiply those numbers together, and I end up getting 96. So that means that the measure of angle A equals 96 degrees. All right, now I need to do the same thing for angle B. According to the problem, the measure of angle B is equal to 3 times x, 3x plus 1. So I'm going to do 3 times 24 plus 1. And then I'm going to calculate what that's going to be. So if I were to figure out what 3 times 24 is, I end up, and again, you can use your calculators. Technically you don't need to, but you can. So 3 times 24 will give me 72. So the measure of angle B equals 72 plus 1, which means that my answer is 73. So I can say the measure of angle B equals 73 degrees. All right, and then the last one is the measure of angle C, which is x minus 13. So I end up getting 24 minus 13. And that means that the measure of angle C is equal to 11 degrees. Now, that's my final answer because it asked me to find the value of x, which I did, and the measure of each angle, which I did. And then all I have to do now is just add up my angles together just to make sure I did it right. So I can add up 96 plus 73 plus 11 adds up to 180, so I know that my answer is correct. Okay, so now in question number 4, it says, in each triangle below, find the missing angle. First thing I want you to do is I want you to change this 115 to 120 degrees because this will be a little bit more conducive to what it is that I want you guys to understand in this lesson. So again, just changing it to 120 degrees, we did not actually we did not actually do anything with the problem yet. I'm just changing the original problem. So what I want to do is I want to figure out what this missing angle is right here. Now I know that this is 50 degrees, and I know that this angle on the outside, which is called an exterior angle, is 120 degrees. Now, if you guys notice, right here, that's an angle symbol. If you guys notice right here, this adds up to 180 degrees. So I can figure out what this missing angle is right here by just subtracting 120 from 180. So that means that this angle inside of here is 60 degrees. Then, based on that information, I can take this 50 and this 60 and use it to figure out what this missing angle is right here. So to do that, I have to add 50 and 60 together, and I end up getting 110 degrees. And then I just subtract 110 from 180 because the angles in a triangle add up to 180. So I end up getting 70 degrees for this missing angle right here. Now, there's something that I want you to notice about the three angles I'm highlighting. These two angles inside of here, the 50 and the 70 degree angle right here, are called remote interior angles. And this 120 degree angle right here is called the exterior angle again. The reason why these ones are called remote interior angles is because they are the interior angles, the inside angles of your triangle that do not touch the exterior angle. And I want you to notice the numbers that you have for your remote interior angles. You've got 50 and 70, and the exterior angle is 120. Hopefully you notice something. We will try the next example just to see if we notice something in this next example, and then we'll talk about what it is that we noticed. All right, so in this example right here, we're given the two remote interior angles, and we're asked to determine what this exterior angle is. So I'm going to figure out what this missing angle is right inside of here. So in order to do that, I'm going to add up the two angles that I do know in my triangle. So 25 plus 80 is 105. And then I'm going to subtract 105 from 180 because the angles in a triangle add up to 180. So this right here is going to be 75 degrees. So I know this angle is 75 degrees. Now remember that this angle here, this interior angle, and the exterior angle make a straight line, which means that they will add up to 180. So I'm going to take 180 and subtract 75 from it to determine what the missing exterior angle is, which is 105 degrees. So this angle right inside of here, this exterior angle is 105 degrees. Again, please notice something from this interior angle and this interior angle. Remember, these are the remote interior angles, and this exterior angle here, and you should notice a relationship. And that relationship is that the two remote interior angles add up to the exterior angle. Let's look at the previous example. 50 plus 70 adds up to 120, so it is true. The sum of the two remote interior angles is equal to the exterior angle. So I need you all to please find some space on your paper, and I want you to write down that the sum of the two remote interior angles is equal to the exterior angle. Okay, so I can apply that information to question number 5. If you notice, I have I have an exterior angle, and I'm given the two remote interior angles, and I know the sum of these two angles is equal to the exterior angle. So if I were to set up an equation, it would say the first remote interior angle, which is 80, doesn't matter which order you put it in, plus the second remote interior angle, which is 6x plus 6, is going to equal the exterior angle, which is 15x plus 5. Then all I have to do is combine my like terms and solve. So 80 goes with 6, so I end up getting 6x plus 86 equals 15x plus 5. Then I have several options for how I want to solve this equation. I'm going to subtract 6x from both sides here. So I end up getting 86 equals 9x plus 80 or plus 5. Then I need to subtract the 5 from this side, and I end up getting 81 equals 9x. Divide both sides by 9, and I end up getting x equals 9. Okay, but the question asked us to find the measure of angle YDC. So I know that angle YDC is 15x plus 5. So over here, all I have to do is figure out what 15x plus 5 is when I plug 9 in for x. So I'm going to say the measure of angle YDC is equal to 15 times 9 plus 5. Then I would figure out what 15 times 9 is, which is 135. Add 5 to it. That means that the measure of angle YDC is equal to 140. Okay, let me just clarify one quick thing. I know that the measure of angle YDC is this angle right here, because if you look right here, it goes from Y to D to C. So that's where YDC came from. And that's the rest of the lesson on angle relationships.